Aha! Welcome. Now, before we start off, I know that you guys are just on the verge of writing your exams. Probably by the time some of you are seeing this, you'll either be right in the middle or post those June 2025 exams. So my message to you, or brief message that I could give you, is that practice deliberately. Know your weaknesses, know your strengths. It's in knowing your weaknesses that you are able to actually transform or change them into your strengths. As it specifically relates to mathematics, when you practice, especially you need to be practicing with past papers. Don't just jump at it and try to do the whole paper all at once, especially if you know that you've been struggling in your performance. Rather, approach it in a context of topic by topic. So what I'm giving you here should be the tools you need to go into past papers and find any question that deals with sketching an exponential function. Now, when you care to combine what I'm about to share with you in here with what we did in the first episode, seeing as this is episode 2. Now, the first episode is just an introduction to functions. It's a quick and brief introduction. It's a 15 minutes video. Go and check it out if you need to. But for those of you that don't need the training wheels or the introduction to concepts, let's go ahead and sketch. Now, as evident, or as you can see on our screen in here, we've got the steps for sketching an exponential function on our screen. So before we talk of the steps, let us remind ourselves what we captured in episode 1. We said the first and foremost important thing about any type of a function is what? The standard notation. Our standard notation for an exponential graph always and forever comes in the form y is equals to what? A multiplied by b to the power of x minus p plus q. Now, it's important for us to remember, what does our q represent? Asymptote and what? It represents two things. And the moving of the graph up and down, the vertical shift. Asymptote and vertical shift. And what for our p? Our p represents what? The shifting of the graph left and right. And x is our input, x is x, y is y, that's our output. And then our a, we are going to assume that our a is equals to positive 1. Meaning, in this specific example, we are going to be looking at in here, we have an example where we are told to sketch the graph of f of x, where f of x is equals to 2x to the power of 2 to the power of x plus 1 plus another 1, right? So it's important for us to note that our f of x is the same as y. So when we say f of x, we're essentially saying y. So in here, I can essentially say f of x is equals to a bx minus p plus q, right? So in this regard in here, for our f of x is denoted always by a b x minus p plus what? Plus q. So, which then says to us, let's look at our formula going backwards. This q, oh, that's our 1. Okay, now that we know that this q is our 1, let's look at what the first step says in there. The first step says we ought to determine the value of the asymptote. Now, the value of asymptote is represented by what? By our q. Always and forevermore. So let's go ahead and check off the first step now. We've determined the value of our asymptote, and our asymptote y is going to be equals to 1. We've checked off the first step. Now, then we are going to the second step. Now, going backwards in our formula. Now, needless to say, our minus p is represented by that positive 1. We'll get into that as to how the graph is shifted at a later stage, right? But that's a shift on the graph left and right. And then this 2 in here represents our what? Our b. Now, the b determines the shape according to the second step. when the b is greater than 1, our graph is going to be increasing like in this situation in here. So that's all we need to know. It's either going to come in this form or this form. So for this specific scenario, we are going to be sketching a shape that is looking like so. So we've determined now our what? Our shape, that our shape is going to be increasing from left to right. So in a nutshell, we've checked off both the first step and the second step. Now, which requires us to move on to the third step. Now, our third step is going to be what? To calculate the x and y intercepts. So let's go ahead and do exactly that. Now, ladies and gentlemen, we still have our f of x in here, just like we've been dissecting it. Now we are going to get into the determining of the x and y intercept. Now, it's important for us to remember that anywhere along the y-axis, according to our Cartesian plane, x is always equals to what? 0. By the same token, or by an inverse relationship, anywhere along the x-axis, y is always equals to 0. So, which is why it's important for us when we are determining our x and y values to actually substitute y equals to 0 when we are looking for our x-intercept. So there's our f of x. Let's substitute that into that. It's important for us to remember that f of x is the same as y. So at the position of y, it's equals to 0, equals to 2x, pardon me, not 2x, but 2 to the power of x plus what? Plus 1 plus our q. Right, and then in the next step, we're going to take this q and transpose it to the other side of the equation. That positive is going to change to a negative. 2 to the power of x plus what? Plus 1. Now, for those of you that are familiar with exponential equations, you already know that we do not have a mathematical way of solving this in here. For those of you that are not well versed, please be sure to check out our upcoming series on exponents. Right, so in here our conclusion, the conclusion we make to the examiner is that there is no x-intercept. We've done all we could, mathematically speaking. We've failed to determine the x-intercept. So that's where we stop. There's no x-intercept. We are done with the x-intercept part. But we are not done with step 3 yet. Step 3 said to determine both the x and y intercepts. So we've only done half the part. So let's go ahead and do the second part where we are determining now the y-intercept. When we are determining the y-intercept, we always and forevermore do what? Make our x equals to 0. So in the position of x, we are going to substitute what? 0. So y is equals to 2 to the power of x. Now our x is equals to 0, so I'm substituting 0 there, plus 1 plus our q, which is our 1. Then in here we have, in the next step, we're going to have y, 2 to the power 0 plus 1. So it's essentially 2 to the power of 1. 2 to the power of 1 is the same as what? It's the same as 2 plus that 1. So it's 2 to the power of 1. Let me just put the 1 in there for nostalgia's purpose. And then you punch your calculator. And then your calculator is going to tell you that your y is equal to what? Is equals to 3. Now, in so doing, we've determined both our y and x intercept. It means that we can now go ahead and say it is safe for us to check off step 3 as done and dusted. Now the next step is to plot at least 2 other points. Now for the 2 other points that we are going to plot, I'm just going to game it out with you together. Now we are on the fourth step, which is to plot 2 other points, right? So the 2 other points, we've got the first point, which is the y-intercept in here. This is where the graph cuts the y-axis. We've got the first point. We need at least 3 points to plot an exponential. The graph cuts the y the y at 3. So that's our first point. We are going to now assume that x is equals to 1. So in this equation of f of x, we are inputting x as what? 1. When x is 1, we put everything in our calculator, and our calculator is going to tell us that our y is equals to what? Yes, our y is going to be equals to what? To 5. When x is equals to 1, we are inputting just 1 where there's x, and then we do the same. We assume that x now is now equals to what? To 2. We input the 2 into the value of x where there's x in the graph, and then we punch the calculator with everything as is. It's gonna give us the value of what? Our y, which is 9. Right, for the second point. So we've got now the other 2 points. Let's plot them. The first point is when x is equals to 1, y is 5. So that second point, y is equals to 5, somewhere way up above in here, right? And the second point is when, right, it got erased somehow. I don't know what happened. I was saying the first point is that where x is equals to 1 and y is equals to what? 5, which is right up around in here. And then the second point is that where x is equals to 2 and y is equals to 9, which is x is equals to 2 in here, and then we move up vertically, and y is going to be equals to 9, maybe somewhere way above in there. Now, after plotting this, we have done everything we could with regards to the fourth step. We've plotted our points, we plotted our x-intercept, our y-intercept, and the other 2 points. Now we are moving on to the fifth step, seeing as step 4 is also checked off, which is to sketch the graph. So let's go and do the fifth step together. So here we are sketching our graph. So we know that the shape of our graph, first and foremost, is determined by what? By the value of b, which we said it's going to look like increasing from left to right. And our graph is gonna approach the asymptote. Now, where is our asymptote according to step 1? Our asymptote is going to be at y is equals to 1. So we are going to plot our asymptote and then now sketch our graph and connect those points we plotted on as per the fourth step in this part, and then conclude this rather long video. So let's start off with our asymptotes. Our asymptote is going to pass where the graph y, the y is equals to 1. Now an asymptote is nothing than a horizontal line that cuts the y-axis at a particular value. So in this case, the asymptote cuts the graph at the line y is equals to 1, right? So that's what I need you to take away for yourself. I'm just going to rewrite that on the other side so that it doesn't interfere with my sketch, right? So this line, there's asymptote y is equals to 1 at this point. It's equals to 2 in here, and then it's equals to 3 in here. So our shape is going to be increasing from left to right. That's what we know about our graph. So now we are simply plotting the graph we know we are supposed to be having, which is going to pass at y is equals to 3. That's where it cuts the y-axis, and then it's going to pass at the point where x is equals to 2 and y is equals to 5, all the way into the point where x is equals to what? 2 and y is equals to 9, and our graph is continuous like so. And after we do that, we can now move on and label our graph. Our graph is f of x. You get marks for labeling your graph, guys. You are supposed to label your graph as well as your axis, and make sure that there is equal space in between your units. 1, 2, and 3. There's supposed to be equal space. So I recommend that you are going to measure the distance of 1 centimeter between 0 and 1, 1 centimeter between the 1 and 2, The same when you're going up, 1 centimeter, 1 centimeter, 1 centimeter. You can count in 2, 4, 6, 3, 6, 9, 7, 14, and so forth. It doesn't matter. You just have to be consistent all throughout your Cartesian plane. So that's it, guys. We've just checked off that 5th step to sketching functions. So with now that we know how to sketch a function, seeing as we've just sketched this beautiful exponential function in here, I will not end the sessions so easy for you, but rather I will end it with something that benefits you for the long haul. Now on your screen there you have a past exam question, question 4, where you are supposed to actually determine the coordinates of the x and y intercept, but consequently you are going to be sketching the graph as per 4.2 is saying, right? So this is your homework. Do this before you watch video 3 or episode 3 of this series, right? In episode 3, that is gonna be me breaking this down or doing this question with you. So for the interim, this is your homework. So pause, take a screenshot, and do the things. If you like the video, please comment below. If you have any questions, comment below. But if you do like it, please do hit the like button, do hit the subscribe button, and be sure to share it with friends and family. This is Math Era. We hope to be inspiring minds. We hope to be shaping the future. Thank you.